Recrystallization is a common technique for the purification of organic solids. Many different solvents can be used in the recrystallization of organic solids. The choice of solvent to be used in a recrystallization depends on the solubility properties of the compounds present in the mixture that you're trying to separate. This demo video illustrates the separation of transenamic acid from urea by recrystallization of senamic acid from water, a solvent suitable for this purpose based on the solubility properties of senamic acid and urea in both hot and cold water. The sample in this demo also contains water insoluble impurities, small amounts of charcoal and sand, which must be separated from senamic acid during this process. We'll start with 0.75 grams of the impure sample, which means that between 0.74 to 0.76 grams must be weighed out. Place a weighing vessel on the balance pan and zero the balance. Note the powdery texture and gray color of the sample, the latter being caused by the presence of a very small quantity of charcoal. The quantities of charcoal and sand in the sample are negligible, and they won't contribute noticeably to the total weight of the sample. Use the broad end of a scoopula to transfer the solid from the stock bottle to the weighing vessel as shown here. If you transfer too much, you can return the excess to the stock bottle. If you accidentally spill solid, please be considerate and clean the balance and surrounding benchtop area. Please remember to replace the cap on the stock bottle. And remember to record the weight of the sample accurately in your notebook to 2 places to the right of the decimal point. The isolation of pure senamic acid from this mixture containing both water-soluble and water-insoluble impurities requires several steps, starting with removal of the insoluble impurities by hot gravity filtration. Then, separation of senamic acid from the water-soluble impurity urea by the selective recrystallization of senamic acid while urea remains dissolved in solution. And finally, isolation of the solid senamic acid product from solution by vacuum filtration, also referred to as suction filtration. We'll begin by setting up the apparatus for hot gravity filtration. Before setting up for hot filtration, transfer the sample from the weighing vessel to a 250 milliliter Erlenmeyer flask. The solid should dislodge easily from the weighing vessel. Don't be concerned with any small specks of solid that might remain on its surface, as its weight is negligible. Set the flask aside in a place where it won't be knocked over accidentally. Now prepare the apparatus for hot gravity filtration. Secure a small iron ring to either a ring stand or to a metal rod attached to the benchtop in your hood. You will use a 125 ml Erlenmeyer flask as your receiving vessel for the filtration. Place it directly under the iron ring. Then place a stemless funnel in the iron ring and center it directly over the opening of the flask. Adjust its height such that the exit of the funnel is below the rim of the flask but not touching it. Obtain a piece of commercial fluted filter paper. If none is available, your instructor will demonstrate how to make fluted filter paper. Place the filter paper in the funnel and the hot gravity filtration apparatus is now ready. Now that you've set up the apparatus for hot gravity filtration, you're ready to dissolve the organic solids in hot water, then perform a hot filtration to remove water-insoluble impurities, and then allow crystals of pure senamic acid to selectively recrystallize from the cooling solution. At this point, light a Bunsen burner, and note that it's only because you're using a non-flammable solvent, water, for recrystallization that you're using a flame for your heat source. To light the burner, the thin-walled tubing that's attached to the burner must be connected to the nozzle of a gas tap. Make sure you're connecting it to a gas tap and not a tap for either air or steam, which may look similar to a gas tap. Partially open the burner intake window to admit air. You will use the spark from a striker to light the flame. Be sure the striker contains a flint and test it by applying pressure to the flint as you force it across the rough metal of the striker's file. Partially open the tap to admit a moderate flow of gas to the burner, then use the striker to generate a spark directly over the opening at the top of the burner. Adjust the flame height by regulating the flow of gas from the tap. Now slightly open the burner intake window to obtain a more blue and hotter flame. At this point, add 90 milliliters of tap water to the 250 ml Erlenmeyer flask that contains the impure sample. Remember to add 1 or 2 boiling stones to the flask. It's only now that you should use a large clamp, either a 2-prong or a 3-prong clamp, to firmly clamp the flask. Using the metal rod of the clamp as a handle, gently swirl it over the flame such that the flame's tip is in full contact with the bottom of the flask. Use a slightly circular motion to gently swirl the flask's contents. You want to avoid the splashing that would occur when you slosh the flask's contents in a side-to-side motion. With continued heating, the cloudy gray suspension will slowly clarify. This could take several minutes. Continue to heat and swirl periodically. As the solution becomes clear, but still slightly gray due to the charcoal, you'll notice some undissolved solid floating at the surface. That's undissolved cinnamic acid, which will dissolve upon further heating. The water will most likely approach a rolling boil before all the organic solid dissolves, but don't heat the solution to such a vigorous boil that it froths out of the flask and onto the bench top. Pay careful attention to what you're doing. You should eventually obtain a clear solution with small particles of charcoal floating or gathered at the bottom of the flask along with a small amount of sand. At this point, quickly and carefully pour the hot solution in several portions through the fluted filter paper. To prevent precipitation of cinnamic acid from occurring in the filter paper while you're filtering the hot liquid in several portions, keep the remaining unfiltered solution in the Erlenmeyer flask hot by heating it briefly over the flame while you wait for liquid to pass through the fluted filter paper. When finished filtering, remove the clamp from the flask before setting it aside, but keep the burner lit for the moment. If filtration was performed correctly, the filter paper should contain charcoal and sand with possibly only a very small amount of white solid or shiny crystals on its surface. The filtered solution will most likely contain solid cinnamic acid product that precipitated when the hot solution cooled rapidly upon contact with the cool glass of the receiving vessel. You need to redissolve it and allow it to recrystallize slowly so that you can obtain a pure product. Add a fresh boiling stone or two to the solution containing the precipitate. Now, firmly clamp the flask and reheat the solution over the burner flame until all solids have redissolved to afford a clear solution. Don't add any more water. You already have enough present to dissolve all the cinnamic acid, and there's no need to filter the solution to remove insoluble impurities since you've already done that. This is a much smaller flask than the 250 milliliter Erlenmeyer flask you started out with, so it's much easier to experience frothing of the liquid out of the flask and onto the benchtop due to overheating, so please pay careful attention to what you're doing. Note that the point of reheating the solution is not to boil water. You're heating it to redissolve the solid. So if a clear solution is obtained before the water begins to boil, you can stop heating at that point. The solution is now clear and no further heating is required. To avoid the flask accidentally tipping over and spilling your product on the benchtop, don't prop up the full clamped flask by resting the handle on a raised surface. Always unclamp the flask before letting go of the handle. Turn off the flame by closing the gas tap. To allow for recrystallization of cinnamic acid to occur, leave the hot flask to cool completely undisturbed in a safe place on the benchtop. As the hot liquid slowly cools, crystals of cinnamic acid will slowly and selectively recrystallize from solution, since it is much less soluble in water than urea, the other organic solid in the original mixture you began with. Over a period of 10 minutes, speeded up approximately 10 times in this video clip, you can watch the crystals of cinnamic acid slowly emerge from solution and then gradually settle to the bottom of the flask. Allow no longer than 20 minutes for cooling, at which point the flask will feel slightly warm to the touch. At this point, you'll cool the flask to an even lower temperature by immersing it in an ice water bath. The solution has now cooled considerably and the flask feels only slightly warm to the touch. You can clearly see shiny crystals of cinnamic acid suspended in solution, only a very small amount remains dissolved. You'll now immerse the corked flask in an ice and water bath to derive as much product as possible from solution by lowering its temperature. Once you've placed the corked flask in a vessel that's large and tall enough to prevent it from tipping over while it's being cooled, a 600 ml beaker in this case, surround the flask with ice chunks. And then add enough water such that the height of the water in the bath is slightly higher than the height of the liquid in the flask being cooled. Set the bath aside and let the flask cool for no longer than 5 minutes. To collect the suspended crystals of cinnamic acid from solution, and that solution is also sometimes called the mother liquor, you need to perform a vacuum filtration. This is an apparatus for vacuum filtration. To assemble, first secure the filter flask to a ring stand or a metal rod in your fume hood using a large clamp. Then use heavy-walled vacuum tubing to connect the nozzle of the filter flask to a vacuum trap assembly, which should already be set up in your hood. The trap is there to collect any overflow of liquid from the filter flask should you accidentally fill it with more liquid than it can hold. Without the trap, the overflow of liquid would go directly into the vacuum pump, which would damage the pump severely. With another hose connecting the vacuum trap to the vacuum inlet, you're ready to place a rubber filter adapter and Buchner funnel on top of the filter flask. Be sure to use a piece of filter paper that completely covers the holes of the funnel, and it's not so big that it rides up the inner sides of the funnel. The apparatus is now ready, and you can collect the suspended crystals by vacuum filtration. Dampen the filter paper with a small amount of the mother liquor, in this case it's water, or you can simply use tap water. Then open the vacuum source, and finally swirl the flask to suspend the crystals and pour the contents of the flask into the Buchner funnel. Once the transfer is complete, add a small amount of fresh, cold recrystallization solvent, in this case it's water, and resuspend any solids remaining in the flask in order to transfer it more easily into the Buchner funnel. Feel free to use a spatula if you need to in order to remove any solid that's clinging to the inner walls of the flask. This liquid also serves to wash the filtrate off the surface of your crystals. Remember, the filtrate, or the mother liquor, contains soluble impurities which you want to remove from your recrystallized product. This is what your purified transenamic acid should look like after you've collected it by vacuum filtration. To demonstrate vacuum filtration, we'll collect the cinnamic acid solid from the flask that's been cooling in an ice water bath for 5 minutes. Use a 250 ml filter flask. The first step in setting up a vacuum filtration apparatus is always clamping the flask to a ring stand. Do this before attaching any vacuum hoses. Rest the flask on the base of the stand. Next, connect the vacuum trap to the vacuum source with heavy-walled tubing. Then use another hose to connect the trap to the filter flask. Place a rubber filter adapter on the flask. This is needed to make a good seal between the flask and the Buchner funnel when vacuum is applied. Place a single piece of filter paper into the Buchner funnel. Make sure it completely covers the holes in the funnel. Open the valve leading to the vacuum source, and then pinch off the small tubing on the three-way plastic connector of the trap to close off the system and create a vacuum. Much of the solid is resting at the bottom of the flask, so swirl the flask's contents to resuspend the solid so that it comes out with the liquid as you pour it into the Buchner funnel. Use fresh, cool tap water to resuspend any solid remaining in the flask. You can use a spatula if needed to remove any sizable amounts of solid still adhering to the inner walls of the flask. Don't be concerned about any small amount of solid still visible on the glass, as its weight is negligible. Add another small portion of water for the purposes of transferring and rinsing. Momentarily break the vacuum to allow the liquid to thoroughly rinse the filtrate off the collected solid. Then reapply vacuum to remove the rinse. In a few moments, you'll notice very little liquid entering the flask from the Buchner funnel. And you can now break the vacuum. Please remember to close the valve to the vacuum source as soon as you finish using it. Leaving it open will diminish the strength of the vacuum for anyone sharing the same pump. If all went well, in the Buchner funnel you should find shiny white crystals of purified cinnamic acid along with any boiling stones you might have added. There is a notable difference in appearance between the impure mixture you started with and the final recrystallized product in the Buchner funnel. You must now transfer your damp recrystallized product from the Buchner funnel into a weighing vessel for temporary storage. Be sure to label the weighing vessel with your name, course and section number, and the chemical name of the product. Use a spatula to transfer the entire contents of the Buchner funnel into the weighing vessel, the product, filter paper, and any boiling stones. To dislodge the filter paper and its contents from the Buchner funnel, you can drag the blade of a spatula around the edge of the filter paper. Then transfer the entire contents of the Buchner funnel into the weighing vessel. Use your spatula to dislodge any solid still adhering to the inner walls of the Buchner funnel. Don't worry about any solid that clings to the filter paper and boiling stones. Once the sample is dry, it will easily become dislodged, and at that point you can discard the filter paper and boiling stones. Place the weighing vessel in your lab section's communal storage drawer and allow the solid to fully dry before proceeding.